welcome back to another video of the channel. My name is Julio. Thanks for tuning in. Before we get started, like, subscribe, hit the notification button, and let's get down to business. So today we're going to be talking about BGP weight, what it is, what is it used for, and what advantages it provides to your network. Let's get inside the details. So essentially, the BGP weight attribute is a Cisco specific value that helps routers select the best path to a destination. It's a key factor in the best path selection process. So how it works. The weight attribute is a numeric value between 0 and 65,535. A higher weight value is preferred over a low one. The weight attribute is local to the router and is not exchanged between routers. The weight attribute is used to prioritize exit pathways from the router towards external destinations. When to use it? When dealing with multiple entry points, when preferring one path over another for reasons such as cost, reliability, or latency, to manually prioritize routes from one ISP over another. And just to give you more information, when implementing BGP on a Cisco router, each prefix within the BGP table is assigned a value for the weight attribute. By default, the weight attribute will have a value of 32,768 for locally advertised prefixes and a value of 0 for all other prefixes. Example of this will be those learned from BGP peers. So here's a picture of all the BGP known attributes by order. And as you can see, the weight and the local preference has the highest preference from all the others. So for example, if you configure weight and a local preference inside your own router, the one that has the weight configured is going to be preferred over the local preference. So let me break it down to you. The first thing we're going to do is we're going to configure the customer router with the BGP and the networks we're going to be advertising. And we're going to select link 2 with the weight, the highest weight, in and out. And as a bonus that I did not mention before, link 1 is going to be configured with local preference. And this is going to be done because I want you to see that it doesn't matter the local preference and the highest number on the configuration. The table said that the weight has the highest preference over the local preference, and I want to show you that. So afterwards, we're going to jump into the carrier router, and we're going to configure the BGP instance. We're going to configure both links. We're going to configure the network that is going to be advertised via BGP. And we're also going to configure the weight with a higher value in and out. And we're also going to configure the local preference with a higher value. So here's the configuration that we're going to be injecting on the customer and the carrier router. We're going to configure the links. We're going to configure the loopback, the route maps, the BGP instance, and the weight and the local preference. So now that I have explained a little bit about weight, let's get inside the CML and let's get started with the lab. Let's get it, guys. All right, so we're inside CML now. We're gonna start configuring the customer router with the route map for the local preference, the loopback interfaces, the WAN links, and the BGP instance. All right, so you're gonna notice that I'm gonna configure just one neighbor at a time. I'm gonna configure link one, and I'm gonna tie the route map that I created for the local preference 200 to the neighbor. And afterwards, I'm gonna configure the other neighbor with the weight. And the reason I'm doing this is because I want you to see that the BGP routing behavior is gonna change after I apply and lift up the secondary node with the weight. All right, so let's jump into the carrier router and start with the configuration as well. All right, now let's do clear IPBGP asterisk stuff in and out, so the route map can take effect immediately. All right, so let's do a show IPBGP. Okay, it hasn't got the update yet. Let's give it a couple of seconds. And there we go. Now the local preference is tied to the primary link. All right, so let's go to the customer router and do the same commands. And as you can see, it took effect here as well. So what we're gonna do now is we're gonna configure the secondary neighbor with the weight now. All right, so now that we finished configuring the secondary neighbor with the weight of 200, we're gonna go ahead and proceed to do the same configuration over on the carrier router as well. Alright, so now that we finished configuring the secondary neighbor on the carrier side as well with the weight of 200, let's do clear IPBGP asterisk soft in and out as well. So let's wait a couple of seconds here. All right, and this is beautiful. Now, as you can see, the weight took precedence over the local preference. And now to reach the 10.1.0.0/24 and the 10.1.1.0/24 from the carrier to the customer router is going to take 192.168.2.2, which is the secondary link that we configured with the weight of 200. Now let's go to the customer router and do the same command. And as you can see, beautiful. Now the weight took precedence over the local preference configuration, and now you can reach the 192.168.255.1/32 via 192.168.2.1. And as you can see by the ping, I can reach 192.168.255.1. Alright, so this concludes our live for today. I hope you enjoyed the content. If you did, please give it a like. And as always, this is Julio. I'll see you in the next one. Peace out.